A very good evening to all of you students. Today we will discuss the hardware specification, pin outs and pin function of 8086 and 88 microprocessor, which is related to the syllabus of MSc 4th semester physics chapter microprocessor. So here 8086 and 88 both the microprocessor are comparisonly similar to each other, only some pins are different. So to understand the pin outs and pin function, first we have to know about the mode of the microprocessor, in which mode microprocessor is work. So there are two mode. Let's see. So there are the two mode of 86 and 88 microprocessor. One is the maximum mode and second is the minimum mode. So what is the minimum and maximum mode, and which pin decide the about the maximum and minimum mode? So when the input IO or memory or and system bus is connected with only one of the processor, then this mode is called the minimum mode. And when the IO memory and system bus is connected with a multiple of the processor, then it is called the maximum mode. These are the figure of 86 and 86 minimum and maximum mode. The pin number 33 decide which mode is microprocessor use in which mode. So if the 33 pin number is active low, that means the microprocessor uses a maximum mode, and if the 33 pin is active high, then the microprocessor is used as a minimum mode. Now both the 88 and 86 microprocessor are same, which I said in first slide, and both are in 40 pin packaged, dual 40 pin package, that means 2021 side. Let's see in the figure. So this is the figure of 8086 and 88 microprocessor minimum mode and maximum mode. So here we will discuss all these 40 pins or dual 2020 pins are present here, dual side. So first of all, from first pin and pin number 1 and pin number 20 shows the ground pin in, and we also called is the VSS pin. Now this pin, this 40, pin number 40, that means this pin is called the VCC pin or supply. This pin actually use in whole microprocessor. The pin number 40 provide the electrical power supply of plus 5 volt. Now come to the point, pin number 2 to pin number 16, which shows in here. This is the AD pin, or also AD pin is another is 39 number, pin number 39. So AD, that means address data multiplexed pin is here. We know microprocessor 8086 is the 16-bit microprocessor. So that means data bus is what, 16, and address bus is 2 to the power 20 is equal to 1 megabyte. 2 to the power 20, we get 1 megabyte. So that means the address bus is what, 20, and the data bus is 16. So here the address and data multiplex pin is up to 16, and remaining 4 pin of address bus is here. That means pin number 38, 37, 36 and 35. So AD pin, that means multiplex pin, and we know the microprocessor only access either the bus or address. So what we have to do, first we have to our microprocessor have to choose which one is transferred, data bus or the address bus. So for this purpose, the pin number 25, that means address latch enable, this pin help the microprocessor. Address latch enable pin is, now if the address latch enable pin is active low, that means if ALE is 0, that means the microprocessor choose the buses choose the carry the data. But if this ALE pin is 1, then buses choose the address. So ALE pin, address latch enable pin, is very important to decide which one is carry data or the address. Okay. Now come to this point, pin number 17. This is the actually NMIP. non-maskable interrupt. That actually this pin is used which cannot be controlled by the programmer. So NMI pin is cannot be controlled by the programmer. Next pin is 18, int r, or we can say interrupt request, so which can be controlled by the programmer. This pin is the maskable pin and controlled by the programmer. Another pin is the pin number 19 is clock pin. All the internal part of the microprocessor is synchronized by this clock. So setting of the time is in this. So one side is clear total. Now come to the pin number A16, A17, 18 and 19. So A16 and A17, that means S3 and S4. Okay, S3 and S4 actually as for the status, and this pin uh, yeah, actually micro in this through this pin microprocessor access the segment, which segment is to be executed. So segment, we know there are the four segment. For the logic 0 and 0 of S3 S4, we get the extra segment, that means microprocessor access the extra segment. For logic 0 1, microprocessor access the stack segment. Okay, for logic 1 0, microprocessor access the code segment, or for logic 1 1, the microprocessor access the data segment. So this is actually the status which segment is accessed by the microprocessor in pin number through pin number 38 and pin number 37. Now pin number 18, sorry, pin number 36 or A18, we can see the A18 is actually interrupt flag. This one is the interrupt flag. If this pin is active high, then the interrupt is present, and if active low, then interrupt is not present. Pin number 35 is reserved for the future purpose. This pin is reserved for the future purpose. Generally in maximum and minimum both mode, this pin is always active low. Now come to the point number pin number 34, that means BHE pin, bus high enable. This pin actually tell us about the how many bit access the microprocessor, 16 bit or upper odd bit, how many bits accessed by the microprocessor. Now the pin number 33, which I already explained, if the pin number 33 is active low, then maximum mode, and if the pin number 33 is active high, that means the microprocessor used as a minimum mode. Now pin number 32 is a active low pin, so which read the data pin. Active low pin only read the data when the 0, because this is the active low pin. Okay, now we come to this pin number 24, which is called the pin number 20 test, sorry, now we come to the pin number 23, that is the test pin. Test pin is used as a wait instruction. After wait, the testing is to be completed. Then ready pin is present in pin number 22. So ready, actually microprocessor is ready to connect with the peripheral devices. So next is the reset, which is not seen in our diagram. This pin is the reset pin, that means pin number 21. So if this pin is reset, that means processor is ready again and all function will be 0 if the reset pin is active high. Now we see that pins which are different for the maximum and minimum mode. Which pins are different, which I already leave that pin, that means the pin number 31 to pin number 24. This pin 31 to pin number 24 is different for different mode. So first of all, for minimum mode, we will take for right side of the content, and for maximum mode we'll take the left side of the content. For minimum mode, pin 13 is hold pin, 31 is the hold pin. That means the processor take hold for this purpose. This pin is used, and to acknowledge about hold is represented by halt. That means this one is the halt pin, and the acknowledgement of hold
is represented by this pin, that means halt pin. Now the pin number 29 is also active low pin. So same for the, this pin is used for the writing, write by the processor, but when this pin is 0, then processor is write the data. Next, the pin number 28 is memory or IO pin. Processor take the data from memory if actually memory is active high. So if the this pin is high, that means 1, then the data is accessed by the processor in from memory, and if this pin is low, 20 number 8 pin is low, that means data is accessed by the IO device. Data next one is the pin number 27. This pin is actually DTR pin. DTR, transmit and request, that means data transmit and request. DTR, data transmit and request pin. So if this pin is high, that means data is transmitted, and if this pin is low, that means data is not transmitted. Simple. Now the pin is DEN, data enable pin. Pin number 26 is data enable pin. If there are data store or buffer is present, then this pin access the data, that means actual data. So data enable pin is access the actual data. Now ALE is already I discussed. If the ALE is 1, that means the address bus is carry, and if the ALE is 0, that means data bus is carry. So next one is the int A, 24 number pin, which shows the acknowledgement of interrupt. So these are the minimum mode pin, and now we will discuss the maximum mode pin between the 31 to 24. Here the 31 and 32, 31 and 32 shows the which pin, RQ and GT not and GT1. This is called the request grant. Only in maximum mode this pin use request, RQ for request and GT for the grant. So request grant, that means we know in maximum mode the microprocessor is used in multiple processor. So if there are two processor, one processor is working and suppose another processor request grant to the system bus, and the system bus granted by this pin. So request grant pin is 30 and 31 pin is request granted pin. Okay. Now the lock. The pin number 23 is lock active low pin. Processor lock the resource before the processing. So this one is the active low pin. Now the pin number 26, 27 and 28. This pin is the status pin, which tell us the condition of in present of a microprocessor fetch are read or from IO or write from IO, halt conditions, all these things, active low, active high conditions. So this is actually the status pin, we can say this pin is status pin. So now pin number 24 is this one is the 24 and 25. Okay, this pin is the status pin also. Actually this pin shows the operation is occurs or not occurs. So the by taking the logic 0 0 0 1 1 0 1 1, we can find the operation is occurs or not occurs. So this total whole condition is in microprocessor maximum mode and minimum mode. Only the pin number 31 to 24 is different for the maximum mode and minimum mode, because maximum mode is used for the multiple processor and minimum mode is used for the uh, single processor. So I think you understand about the maximum and minimum mode, that means the hardware specification or pin outs and pin in functions of the 86 or 88 microprocessor. Thank you very much.